All right, let's start going through the bell work. On the first one, there's something that I notice in my denominator. It's also present in the numerator, and it tells me what my first step here should be. X squared. Especially when you see it in the denominator, but even when it shows up in the numerator, that means the very first thing I need to do here is factor. There is no GCF. That's the first thing I'd want to look for when I'm factoring, correct? All right, so that numerator, I'm going to go ahead and do an X for the numerator. Can I use the shortcut on the numerator?
No.
No. So I'm going to multiply A and C together. That means I'm multiplying 2 and negative 4. I need two numbers that when I multiply them, I get negative 8. But when I take those same two numbers and I add them together, I get positive 7. Thank you, sir. 8 and negative 1. And you said I couldn't use the shortcut. Why not?
Because the x squared is bigger than 1.
Yes. A is 2, and there was no GCF, so I can't get A to be 1. The only time I'm allowed to use my shortcut is when A is 1. So I put my A and my C in the area model. Take those two numbers that we found, positive 8x and negative 1x. Remember, they have to have the x's on them when they go back in, because together they combine to give us that positive 7x. All right, then we're going to look at two boxes at a time. What can I take out of 2x squared and negative 1x? X. What about 8x and negative 4?
Positive 4.
Positive 4. So I have x plus 4 here. And then vertically, 2x squared and 8x?
2x.
2x. And negative 1x, negative 4.
Negative 1.
Negative 1. So my numerator is going to factor to be x plus 4 and 2x minus 1. For the denominator, we said there was no GCF here. I'm going to need to make an x for this. Can I use the shortcut on the denominator?
Yeah.
Yes. So when I multiply A and C together, I'm multiplying 1 and negative 12. Two numbers that multiply to give me negative 12, but add to give me a positive 1.
Negative 3 and 4.
Negative 3, positive 4. And because I can use the shortcut on those, that means my two factors down here are what?
X minus 3, x plus 4.
X minus 3 and x plus 4. All right, so we've factored absolutely everything we can. Do you see anything that will cancel?
X plus 4.
X plus 4. What does that mean?
That means that the whole's x is located at negative 4.
Yes. There is a whole where x plus 4 equals 0. The thing that cancels gives me my whole.
So it's going to be a negative?
It is going to be at negative 4 because I can't have zeros in the denominator.
Okay.
That gives me an undefined value. So if x plus 4 equals 0, I'm dead in the water. So we have x plus 4 equals 0. I'm going to solve that for x by subtracting 4 from both sides. And so the x part of the ordered pair for the whole is negative 4.
And from here, we can either go for the asymptotes or finish off the whole.
Let's finish off the whole first.
Alright, so fill in all the x's, remaining x's with negative 4.
So here's what we had left over after we canceled. So we're going to do y equals 2, and then we're going to put our value for x in there. You okay? Got it. Got it, got it. So 2 times negative 4 minus 1 over, and then I'm going to put negative 4 in here also. So anywhere there was an x, I'm filling it in with the x part of the ordered pair for the whole. What is 2 times negative 4?
Negative 8.
Negative 8.
Negative minus 1, negative 9.
Negative 8 minus 1. So I have negative 9 up on top. Down on bottom, I have negative 4 minus 3.
Negative 7.
Negative 7. What is a negative divided by a negative?
Positive.
A positive.
And this might, I cut it off at the 1,000, so that would leave us with 1.285.
1.285. The decimal form becomes really important if we're going to graph it so that we know what two whole numbers were in between. I don't care about the precision when we're graphing beyond, do you know what two whole numbers it's in between? Because we're just going to make a big circle there. Because again, just like when they give us the weather or when they tell us where the accidents are outside, the most important thing is that you get the general location so you know to stay away from it. That's what I'm interested in. We can give the precise location with the ordered pair, but when you graph this, you want a big open circle at negative 4 and then in between 1 and 2. Okay? Are we done?
Nope.
No, what do I still need? Asymptotes. Okay, so I'm going to go back to what we had left over. I circled it with black here. When you look at this, can you tell me what AH and K are?
No.
Then what do we have to do to get it into that form?
Division.
We have to do some long division.
So put 2x minus 1 under the box and put x minus 3 out in front.
Absolutely. Okay, so let me get that drawn. Scoot this stuff off to the side. You said x minus 3 out at the front because that's my denominator. 2x minus 1 goes underneath. We're going to look just at the x's then, and what goes up on top?
2.
2.
And then make sure you multiply x minus 3 by 2 and then switch the signs.
Multiply the 2 by both pieces out here, so that's going to give me 2x and negative 6, and then you said we're going to switch both signs. So this becomes a minus, but this becomes a plus. 2x minus 2x, that cancels. What's negative 1 plus 6?
Positive 5.
Positive 5. There's my remainder, my a value.
So now you can rewrite it into AHK form.
Now we can rewrite it into AHK form, so this would be y equals what?
2 over x minus 3 plus 5 at the back.
And how does that help me answer the rest of the question?
A is 2, h is 3 positive, and k is positive 5.
So what is our horizontal asymptote?
Y equals 5 positive.
Y equals positive 5, yes. Horizontal asymptote, y equals 5. So what is our vertical asymptote then?
X equals positive 3.
X equals positive 3. So we have the whole up here that we got from the factor that canceled. The x part comes from taking that factor and setting it equal to 0. The y part of that ordered pair for the whole comes from taking our x and subbing it back to what's left over. Then we have to get it into transformation form to find the other two asymptotes. Sometimes after we do our canceling, we just have a number left up on top. If it's just a number up on top, we are in transformation form and k is 0. If there's still x's up on top, then you have to do long division. So that's why we kind of built this slowly over the course of 6 days. We started with just here's transformation form, here's how to graph it. Then we practiced doing our long division and graphing it. And now we've added this last piece in. No more graphing for this unit other than in practicing it on the bell work between now and your test. Does anybody happen to know when the test is?
I feel like it's this Friday.
It is not this Friday, thank goodness. Not next Friday. I wish I could push it out that far. It's next Wednesday. So it's a week from tomorrow.
Is it all the tests on Wednesday?
Hmm?
Isn't it all the tests we took on Wednesday?
All the tests? No. Before break, we took it on a Thursday. Sometimes we take them on Fridays. They're not always on Wednesdays. So do you have a question, Genesis?
Okay, for the remainder and your A, so
Mhm.
how did you get your 2x and A when you did transformation?
Oh, thank you. Thank you, thank you. Did you guys hear Genesis' question? Okay. So she said we had a 2 up on top, and we had 5 as our remainder. And she said, doesn't that mean that we have the wrong thing up on top? And you are absolutely 100% correct. Thank you for catching that. I got rolling too fast. Whole numbers aren't parts of fractions, right?
I just realized that as well.
Yep. Whole numbers are not parts of fractions, so K should be the 2. That changes my horizontal asymptote. And the A value up on top, remainders are still parts of fractions. Thank you so much for pointing that out.
So with the whole, does it always for the signs?
For the whole?
Yeah.
Well,
It's a, okay.
yeah, we always take whatever canceled out, and we'll set it equal to 0. So if it's just x plus something or x minus something, yeah, we're just going to see the sign switch.
Okay.
If what canceled out was something more like 2x minus 1, we're going to see the sign switch, but it's not going to come out as a whole number because of that coefficient out in front. Yes, sir?
I looked in a nurse with my teeth first.
Absolutely. Give me just one moment. All right. Main Street Media sells all DVDs for one price and all books for another price. Hazel bought 4 DVDs and 6 books for $170, while Finn bought 3 DVDs and 8 books for $180. And we want to write a system of equations for this. So I want to know, what are the 2 things we're looking for here? What are the 2 things that we want to know?
The pricing of the DVDs and books.
Pricing of the DVDs, pricing of the books. So we're going to pick 2 variables for that. Are you guys okay with D for price of DVDs? Okay, so let D equal the price of one DVD. If I'm going to let D be the price of a DVD, what should we let the price of a book be called? Sounds good. B equals the price of one book.
Also, we can go off the assumption that books are $5 more expensive than DVDs.
Possibly. Tell me how you got that.
So $4 and $6 is $170. 3 DVDs and $8 is $180. So by taking off 1 DVD and adding in $2,
So you're pretty sure there's a difference of $5 between the 2, but that means one could be 5, the other could be 10, or one could be 15, the other could be 20. We need to find the exact price. But I like your thinking because that helps us, as we get to the end, judge the reasonability of our answers. Yes. Do we have starting amounts and rates? Or do we have totals? Totals. What are the totals that we have? 180 and 170. Let's start with the 170. Who had the total of 170? Hazel. How did she get up to that total? 4 DVDs and 6 books. So we have this total, so equals 170. How would I represent 4 DVDs and 6 books? Yes. 4D plus 6B is equal to 170. What was the other total? 180. How did we get up to a total of 180? Three DVDs plus 8 books. So 3D plus 8B. If I add these together right now, will one of my variables cancel? No. So we're going to have to do some multiplication to get it to that point. Do you want to make the DVDs or the books cancel out? DVDs sounds good. So I'm going to need to multiply both of these equations. If I want to make the DVDs cancel, what can I multiply the numerator by? 3. So I'm going to take a 3, I'm going to distribute it to every single piece. So I'm going to get 12D plus 18B equals, and then I need help from somebody with a calculator because I can't do this one in my head. 170 times 3. How much? 510. What do I multiply the bottom one by?
4.
I heard two different numbers. I heard positive 4 and negative 4. Negative 4. Why negative 4? Yes. I want one positive and one negative, but same number out in front so that when I add them, they cancel out. So I'm going to distribute this negative 4 to each piece. So I get negative 12D minus, what is that, 32B equals negative what? Negative 720. Now I can add these two together. The D's cancel. What's 18 minus 32? You said 14? Negative 14, okay. Equals 510 minus 720. Negative 210. And then I divide both sides by negative 14. You said 15?
Negative 15. It'll be negative 15.
But we have a negative 210. And then a negative 14. Correct. Proud of you for being on it with the signs, though, because I miss those way more than I should. Okay, so B is 15. What does that mean?
$15.
Yep. Each book is $15. Have we answered every question?
No.
What else do we need? Still need to find the price of the DVDs. Tell me how to do that. Substitute. Which equation do you want to substitute into? First thing I heard was the top one, so I'm going to go with that. Does it really matter? We should get the same answer either way. All right, I heard top one first. So 4D plus 6 times, we're going to put 15 in the place of B, equals 170. What is 6 times 15? You said 90? Equals 170. So then I'm going to subtract 90 from both sides. Need to make this all just a little bit smaller. What is 170 minus 90? 80. So I have 4D equals 80. Divide both sides by 4. And we find out that D is what?
20.
D is 20. What does that mean? $20 for each DVD. Nice work. Thank you. She's actually not here today. Thank you so much. Awesome.
So if I find some 5.
I was just getting ready to mention that before the knock on the door happened. It is $5 difference between each of those. So your reasoning from the beginning made sense. We just needed to go about finding those two answers. But that is nice when you make some predictions at the beginning and then you use that to judge how reasonable are your answers when you get to the end. All right. We're going to roll on to everybody's favorite. I know how much you guys love story problems. Everybody loves story problems. These are probably some of the most fun story problems I've ever done before, though. We're going to be on page 212. Joe can paint a house in 3 hours. Sam can paint the same house in 7 hours, or sorry, in 5 hours. How long does it take them to paint the house together? Just knee-jerk reaction. You read this problem, what do you think? 4 hours? Tell me why. Between 3 and 5. You are literally the first person in 8 years of teaching that has not said immediately, 8. I wish I was joking. I'm 100% honest right now. Why do you think people say 8 off the bat? They're just adding those two together. They see together, they add them. Tell me why 8 doesn't make sense. Yeah, why would they work together if it's going to take them more time? I'd be like, no, you're distracting me. Go home. Okay, so let's talk about how to figure it out. 4, I think, is a reasonable guess. It's certainly going to guide us. It's in between 3 and 5. Let's see. I'm going to write a rate for Joe. What is Joe trying to do?
Paint a house.
Paint a house. How many houses? 1. So we have 1 house in how many hours?
3.
3 hours. So this is Joe's rate. What about Sam?
1 house over 5 hours.
1 house in 5 hours. So that becomes Sam's rate. They're both pretty fast. I don't think I could paint a house in 3 hours or 5 hours. I could probably use a paint sprayer, but I'm not going to be doing the trimming and all the nice cleanup stuff.
But how many coats of paint you have to put in order to get a solid color? That is impressive.
Right? Maybe it's one of those 1-coat paints that never actually takes 1 coat. If they're going to work together, how should I represent that? What operation in math do we use if we're going to put things together? Addition. So for the together part, I'm going to use addition. And their goal at the end is to have painted how many houses? 1 house. Do we know how much time it will take them? No, so I'm going to call it X hours because I don't know how long it's going to take. You doing okay?
Yeah.
Okay. All right, so now I'm going to rewrite this, but without the words in there. I put the words in there so that I knew I set it up right, and I had the correct fractions that made sense as a rate. So I've got 1 over 3 plus 1 over 5 equals 1 over x. Now, we know from what we did before break that if we're going to add fractions together, we have to have what? Common denominator. But this time we have something that we didn't have before break. What is this? We know what it's equal to. When I have an equal sign, I have the ability to get rid of fractions. I can't do that without the equal sign, because with the equal sign, I can do things like if you do it to one side, you do it to the other. But when I say the other side, I mean the other side of what? Of the equal sign. So without an equal sign, I can't use those rules. But once I have an equal sign, I've got some extra tools that I can use, and I can get rid of fractions. We're going to use something called the LCD, the least common denominator, to get rid of our fractions.
1.
I want you to look down at all the denominators. I've got a 3 down here, so I'm going to put that in the list on my LCD. Thank you, ma'am. I'm going to move on to the next denominator. Is this denominator a 3? Is this one right here a 3? Is it a multiple of 3? Nope. Then I'm going to write it down as part of my LCD with a times sign next to it. Then I'm going to move on to my last denominator, which is what? X. Is that a multiple of 3?
No.
Is that a multiple of 5?
No.
Then it goes on my list.
Well, maybe. Maybe once you figure it out.
I'm going to multiply every single fraction by this LCD. So I'm going to multiply my first fraction by 3 times 5 times x. Second fraction gets multiplied 3, 5, and x. Third fraction 3, 5, and x. And hopefully you guys remember, if there's something the same between the numerator and the denominator, what happens? Becomes a whole number. Which whole number if it's the exact same? 1. So like here on this first fraction, those 3's are going to cancel. What does that leave me with? Yep, 1 times 5 times x, which is 5x. I'm going to bring down my plus sign, and I'm going to go over to the second fraction. Is there anything the same between the numerator and the denominator? The 5. What does that leave me with? 1 times 3 times x. What is 1 times 3 times x? 3x. Bring down my equal sign. Anything the same between the numerator and the denominator here? The x's. So what do I still have? Yep. 1 times 3 times 5, which is 15. And just like that, we took it from a problem that had 3 fractions into a problem that has no fractions. Thank you, equal sign. Without the equal sign, that's not possible for me. I have to keep working with fractions. But with an equal sign, I can get rid of them. Can I combine any like terms together? What is 3x plus 5x? 8x equals 15. What do I do from here? Divide both sides by 8.
Be a little bit less than 2 hours.
A little bit less than 2. X is equal to 1 point what? Grab your calculators for me.
875.
1 point, how much?
875.
875. Do we have units with that? Hours. Beautiful. 1.875 hours. The original guesstimate here, just reading the original problem, was that it was going to be somewhere between 3 and 5, somewhere around 4. What would Joe's incentive be if it was going to take him longer if he works with Sam?
Don't look at Sam.
Don't work with Sam, right? So if they're working together, I would expect it to not just be less than what Sam can do by himself, but also what Joe can do by himself. Otherwise, Joe doesn't want to work with Sam. I've been in those kinds of groups before. I can do this in 2 hours on my own or 3 hours working with y'all. I'm going to stay by myself. Do you guys want to try another one similar to this? Okay. We do have time. What do you know? One weekend, Terrence threw a party at his house when his parents were away. Womp womp. It took him 4 hours to clean the house before they got back. The next weekend, Jamal threw a party, and it only took him 2.5 hours to clean up the house. How much, I think that's supposed to say time, not tie. How much time would it take the brothers to clean if they did it together? Can you help me write a fraction for Terrence?
What if it was a tie party?
Good question. Help me write a fraction for Terrence. How many houses is he trying to clean? 1 house. How long does it take him? 4 hours. What about Jamal? One house in two. How should we represent 2.5? 2.5. Okay, so now I have rates for both Terrence and Jamal. What do I want to do with those rates? Add them because it says what? Together. That word together is how I know I'm adding. And so what's it going to be equal to at the end?
X.
1 house over x. I have no idea how long it's going to take them to do it together, but at the end they're going to end up with 1 clean house. So 1 over 4 plus 1 over 2.5 equals 1 over x. Let's go find our LCD. This is what we're going to multiply each fraction by. What number do you know I need in my LCD? I need x. That's this denominator right here. What else do I need as part of my LCD? 4 and 2.5.
So what happens if they are multiplication of each other?
If they're multiples of each other, then I would only, let me give you an example. Like if instead of 2.5, if it was 8 down there, 8 is 2 times 4, right? Well, I already have the 4 here, so I would only need to include the piece of the denominator that's not already up there. So I'd write it down in its factored form and then just grab the new factor that I don't already have.
All right.
We'll practice that tomorrow too. So I'm going to multiply by my LCD. So I have x, 4, and 2.5 times x times 4 times 2.5 times x times 4 times 2.5. What's going to cancel in my first fraction? 4s. So I'm going to end up with 2.5x, because that's what I've got left over. Plus, what will cancel from my second fraction? 2.5s will cancel, which means I have what? 4x equals, what do I cancel here? Cancel the x's, so I have to multiply the 4 and the 2.5 together, and I get what? 10. Do we have any like terms to combine? What do I get when I put those together? 6.5x equals 10. Let's go ahead and divide both sides by 6.5. And that gives us what? You said 1.538? Do we need units with that? Hours. How are you guys feeling about these? Pretty reasonable as far as story problems go? I told you, these are probably some of my favorite story problems because when I read through them, I'm like, okay, what's the first person trying to do? And I'm going to write down a rate for them. What's the second person trying to do? And I'm going to write down a rate for them. Put them together, and I write my final rate. Yes, ma'am?
Are we gonna have to do like division or multiplication of problems?
Problems like these are going to stick to addition and subtraction. Good question.
So, you know how it took Jamal 2.5 hours to clean up? How would we write that if it took him 2 1/3 hours?
Ooh, good question. You would have to keep it, you would have to write it as an improper fraction first, and then we would have to multiply by the reciprocal. Ms. Bolt? I wish that I could say that it was that straightforward, but because of the division involved there, it won't be.
If you did the rounding, then yeah, but...
Yeah, like you could approximate it. Yeah, you could approximate it that way. Or that would give you a good idea of like what to think. Oh, I think my answer is going to be close to this. As an estimation technique, that's not a bad technique. Let's do one more and we'll call it a day, okay? It takes Sam 25 minutes to eat an entire bag of Cheetos. That must be an enormous bag. Or he's distracted. When Sam and his friend Dylan eat a bag of Cheetos together, it only takes them 14 minutes. How long does it take Dylan to eat a bag of Cheetos? What should this look like as I set it up? 1 over 25. What does 1 over 25 represent? This is Sam. This is 1 bag of Cheetos and 25 minutes plus 1 bag in 25 minutes. And then you said I'm going to add that to what? 1 over x. Why 1 over x? Yeah, this is Dylan.
But we know how long it takes for them both to eat it together.
We know how long it's going to take them both to eat it together, which is what?
minutes.
1 over 14. 1 bag of Cheetos, 14 minutes. Okay, so I'm going to write it down as just the fractions. I'm going to take the time each time to write down my ratios with the words because I want to make sure I have it set up right. But as you guys are practicing this and getting faster and better, if you jump right to the ratios, I'm not going to take off points. What should my LCD be? I heard 25 times what? Times x times 14. That's what I multiply each and every fraction by. So what cancels out in my first fraction? 25. That's going to leave me 14x plus what cancels out in my second fraction? X cancels out, so I need to do 25 times 14.
350.
You said 350?
Yep.
Okay. Equals what? 25x. So how do I do this? It's a little bit different than before. I can subtract 350 from both sides. I get the x to the same side first if I want to. How would I get the x's to the same side if I wanted to do that first?
So it's equal to 0.
I can set it equal to 0, but I can do it in just one step. I can subtract 14x from both sides. So I would have 350 equals, what's 25 minus 14? 11. And then I'm going to divide both sides by 11. And we get that x is approximately what? We'll go out to 2 decimal places here. 31.8.
31.82.
Depending on how you round. Again, I don't get picky about that very last digit. Should we have units on this?
Yeah,
Minutes. Beautiful. Tomorrow we're going to practice doing this, but without the story. We're going to focus just on the equation part of it. Your next homework assignment, your last homework assignment of this whole unit is due on Friday. You can start working on the ones that have story problems. Like I said, we'll practice ones that don't have stories starting tomorrow, and we'll continue that on Thursday. We're going to have 3 days of review for this unit, Friday, Monday, and Tuesday, because there's a lot of graphing and there's a lot of little places to get lost in the graphing stuff. All right? I hope you guys have a fantastic rest of your day, and I'm going to go ahead and pop the announcements on for us.